Hello everyone! In this issue we will consider the concept and definition of technical assignment in value design engineering. Evaluate the degree of analysis of domestic and international regulatory documents regulating the formation of technical assignments. This document will be analyzed from the point of view of applicability to the basic elements of the theory of value analysis, namely structural and functional model, in the process of its formation and analysis. The reason for considering a technical assignment in such context is the structure and content of technical assignment, containing elements of both models or structural and functional models, as well as my practical experience in the formation of structural and functional models using technical assignment for the development of various mechanical engineering products. Related issues that will also be touched upon in passing of our narration are information support for managerial and design engineering decisions, support for commercial negotiations, and setting targets for direct costs for individual components of the products. The issue of technical assignment formation in the context of value analysis methodology relates to Block 2, School of Value Design Engineering of training course, Cost Engineering. As part of the discussion of today's topic, the following keywords will be used. I recommend the viewers of our channel to familiarize themselves with these keywords before watching this video. Speaking about the analysis of regulatory documentations, in this case, we mean not only an attempt to find existing domestic and international regulatory documents regulating the formation of a technical assignment for the object of analysis related to mechanical engineering, but an analysis of their structure and content in order to identify analogies with the methods of value analysis. In particular, the methods of decomposition and the methods I note that when forming structural and functional models of components at the initial stages of the project, the designer, as a rule, does not have a full set of design documentation, drawings and 3D models or 3D layouts, but has some rough sketches and technical specifications, and then a technical assignment. Thus, the analysis of the mentioned regulatory documents for their suitability for use in the process of conducting the value analysis has not only academic but also purely practical interest. Technical assignment for the product is a quintessence of an integral representation of the concept of product requirements by various project participants. And our training course within the framework of value design engineering concept, i.e. from the applied point of view of a designer cost engineer, the technical specification for the product can be conceptually presented as follows. Concept number 1. A text tabular model that displays the physical design structure of the product at the highest possible level of abstraction by describing it in the relevant sections of the document. The concept number 2. A text tabular model, or TTM, describing a complex of consumer, technical, operational, and other product functions that are significant from the point of view of the specialization of product participants at the highest possible level of abstraction. And the concept number 3, text tabular model of conditional distribution of roles of project participants and the list of works on the projects. In the cost engineering training course, all 3 concepts listed above will be indirectly affected. We will now formulate definitions of the concept of technical assignment, or TA, within the framework of this concept, so as not to drive ourselves into the framework unnecessarily, especially since the above concept of terms of reference, except for the item other possible concepts, are described in the sufficient detail due to their applied nature. Hence, the definition of the term technical assignment within the framework of both concepts will almost completely coincide with the formulation of the concept itself. Let's consider the above concepts of the terms of reference in more detail. Concept number 1 and concept number 2. The combination of structural and functional model which we are talking about in the case of considering the first and second concept of technical assignment is a list of sections and the technical assignment according to GOST 15016 included in the section Technical Requirements, the description of the requirements for the component of the product given in this section of the GOST. Examples of such a description, i.e. in fact an example of technical assignment for a product and technical assignment for a component, will be considered by us below as part of an example of the formation of conventional and alternative forms of technical assignments. And about concept number 3. The conditional distribution of the roles of project participants and the list of works on the project corresponds to the sections of technical assignment, i.e. on the basis of the section technical requirements of abstract structural model and abstract functional model can be formed, which can be used by design engineers for local purposes. For example, decision making at the early stages of the project, at the pre-project, abstract structural and abstract functional model that can be used by reliability specialists. See the section reliability requirements of the GOST 15016, who consider the product as an abstract object that meets the reliability requirements. Transportation and storage specialists see the section transportation and storage requirements of GOST, who consider the product as an abstract object in terms of the presence of structural elements that have functions that allow for the transportation and storage, etc. For example, a hatch in the bumper of a car that closes the attachment point of the transporting line, and etc. Okay, about slide number 4. In domestic practice, in terms of regulatory documentation used in the formation of technical specification or technical assignment within the framework of the Unified System of Design Documentation, or USDD, for a machine building object, everything is quite unambiguous. In particular, we are talking about the GOST 15016 technical assignment requirements for content and design. Below is an analysis of the content of the main section of GOST 15016 with the comments of the analogy with the value analysis methodology and the possibility of using data from the relevant section of the technical assignment in the formation of structural and functional model. In international practice, in accordance with the regulatory documentation available in the public domain, standards are used for many criteria similar to GOST 15016. These normative documents are published by the most well-known organization in the field of standardization. For example, Society of Automotive Engineers, American Welding Society, National Institute of Standards and Technology, American Society of Testing and Materials, International Organization for Standardization, ISO, International Electrotechnical Commission, European Committee for Standardization, European Committee for Electrotechnical Standardization, British Standards, and etc. Okay, separately, we should focus on the group of standards named British Standards, structurally quite close to GOST 15016. In particular, we are talking about the group of the following documents. As the name implies, the first part of the technical of standard deals with general issues of preparation of technical specification, formulation, structure, etc. The second, formulation and definition of criteria for declaring products compliance with the existing standards of specific industries, declaration of conformity. The third, formulation and definition of criteria for declaring products compliance with standards in the field of performance. To the differences, the BS 73731 2001 standard from GOST 15016 2016, I can attribute to the presence in the text of an extremely detailed section with recommendations on wording, i.e., when formulating the names of sections and functions of components, it's necessary to use a group of certain terms, verbs, given in the standard, as well as section describing the required level of detail or level of abstraction, written, however, using fairly general phrases, so I do not see much practical benefit from the description of this section. I thought the reference itself, the level of detail or the level of abstraction, to use the terminology of value analysis, is quite interesting. In GOST 15016 2016, in terms of terminology used in the level of detail, in design engineer is given almost complete freedom. The list of typical sections and subsections characteristics of the object of the standard BS 73731 2001 is presented in the form of numerous tables and fighters, which is, in my opinion, makes the standard a little more easy in terms of information perception. In addition, the annexes to the BS 73731 2001 standard contain a list of BS standards for various industries that can be used in the formation of the technical assignment. Formation of technical assignment by GOST 15016 2016 doesn't provide such a list. However, in the scope section is indicated that this standard applies to the mechanical engineering and instrumentation. At the same time, in GOST 15016 2016, there is no direct indication that the standard establishes the procedures for formation of technical assignment. Contains a section called Technical Assignment for R&D. In BS 73731 2001 standard, in turn, there is no direct mention of R&D. There is no such section. However, in the introduction to the document, it's indicated that the standard can be used in the process of development, production, creation of business processes, and provision of services. In terms of content, GOST 15016 2016 covers in the areas of all three above-mentioned parts of BS 7373 standards. Ultimately, it cannot be concluded that any of the two standards under consideration is more universal or comprehensive. At the same time, the mutual addition of these standards with elements missing in them, or the use of both standards in the formation of technical assignment, could improve the final result of the work in terms of ease of perception and completeness of the display of developed object. There is no publicly available regulatory documentation on the issue of describing the business processes of verification and approval of technical assignments, since both of these processes directly depend on the business processes used in the company. Theoretical consideration of the verification process, in my opinion, doesn't make sense since business processes as a purely applied issue. The slide shows a list of positions of specialists and managers who, as a rule, face a similar need for verification and approval of technical assignment in the process of project implementation. The process of verification and approval by individual of these specialists will be considered by us in the framework of practical cases, corresponding block of the course Cost Engineering. What about analysis of GOST 15016 structure in case of section scope of application? The electrotechnical industry, unlike mechanical engineering, isn't included in the list of industries that we consider as part of cost engineering training course for two main reasons. Firstly, I haven't practical experience in designing electrical products. And secondly, there is an obvious need when using a cost engineering training course, the method of analysis applied to electrotechnical industry. In this case, is a refinement of the classification of functions used in the formation of functional models, since if in mechanical engineering a function of seed formation, for example, is generally speaking quite significant. And in some cases, the main function of the object of analysis, then in the electrotechnical industry, the function of seed formation or positioning is provided by a printed circuit board or PCB, which is one of the least expensive and least functional significant elements of the product. The business processes of construction, content presentation, design procedure for approval and approval of technical assignments, as already mentioned above, may be different depending on the company as a sub-branch of mechanical engineering. Okay, about sections, terms and definition of GOST 15016. Because to get acquainted with this content of GOST 15016, requirements for content and design, any of the listeners can easily perform simple manipulation in the browser search bar. Then I will limit myself to brief review of individual sections of the document in order to determine the presence or absence of elements interesting from the point of view of the criteria outlined above, allowing some parallels to be drawn with the approaches used in the value analysis. At least three concepts from the section terms and definitions. There are customer, developer, and the product have their analogs in cost engineering. Concept number one. In GOST 15016, an organization engaged in product development in accordance with the established procedure is designated as a developer. In cost engineering, as a rule, an organization engaged in product development, design documentation development, and with the purpose of ordering additional analytical work, value analysis, and other types of analysis. To optimize design documentation is designated as a customer. Concept number two. By operator or operating organization in cost engineering, we mean an organization based on information from which the degree of satisfaction with consumer functions is assessed. With a certain stretch, it can be argued that GOST 15016, the operating organization, is designated as a customer. The operating organization receives information about the degree of satisfaction from the users, final users, i.e. its customers. Formalization of information on the degree of satisfaction with consumer function can be implemented both of the format specified cost engineers and in accordance with the GOST ISO 1004 customer satisfaction guidelines for monitoring and measurement. The issues of assessing the degree of customer satisfaction in GOST engineering will be discussed by us in video block 1 entitled Functional Model, the degree of satisfaction and performance for the function. Concept number 3. The meaning of the term product given in GOST 15016 in the cost engineering is similar to either the term product, upper level project of analysis, or term component or element of the product. It's difficult to draw a more precise analogy since the are no explanation in GHOST 15016 about the product being included. About section abbreviation. In the section abbreviation in the context of value analysis, perhaps only two abbreviations: structural part and product component of intersectional application. It's a very specific abbreviation. It's used only in this GHOST. For the abbreviation structural part, we have paid attention because further in the text it's used not only relation to physical object of product, see structural part of product in section 6.1.3, but also in relation to the performance of certain works, structural part of work of labor intensity, see section 5.1. In the value analysis, there is no concept similar to the concept of structural part of work labor intensity and the concept of object of analysis. Component or product component is applied to the concept of structural part of the product. With regard to the abbreviation PISA, or product component for intersectional application, we can say that it's analog of the concept of purchase part used in the course cost engineering. It should be noted that the concept of purchase part is also mentioned in the GHOST 2.106, named specification or technical assignment in English. Its meaning fully corresponds to the concept of purchase part used by us as a part of training course of cost engineering. Consider the sexual general provisions of GHOST 15016. Subsections 5.1 states that technical assignment is an integral part of the contract or agreement for the performance of work on the development of product part of intersectional application. With regard to the implementation of the value analysis and the formation of the value analysis reporting data, the situation is not so unambiguous, i.e. the value analysis is not mandatory but can be included in the list of works under the contract. In most cases, the need to implement the value analysis is due to the need of the developer to manage the costs of the product component for intersectional application at the early stages of design. In addition, this subsection indicates that the development of technical assignment takes into account information about the similar products contained in various databases. The warning is rather vague, but the following parallels are clearly traced. During the value analysis, in addition to the formation of structural and functional models of the analyzed product, cost engineers use structural and functional models of products of the previous generation, as well as structural and functional models products of competent companies. Without the use of this information, the analysis of structural and functional model loses its meaning. Since one of its main goals is to compare the cost of implementing similar consumer functions either in products of different manufacturers or in products of different generations. Regarding the formation of the database of the value analysis, the issue will also be considered within the framework of Block 1 of the concept engineering course. We are talking about the concepts of simplified and complex databases of value analysis, different from the content, different in content, forms, and costs for organizing data storage, PDM and ERP, and etc. Subsection 5.2 of GHOST 15016 states that the technical assignment is approved by the customer. The value analysis also applies a similar approach to the coordination of structural and functional models after their formation on the first approximation. In addition, the List of consumer functions included in the functional model must be agreed by the customer and fully comply with the section additional options of the terms of reference and the option list formed by the customer's marketing department. Consider the section requirements for the construction, content and presentation of technical assignments according to GOST 15016. Section 6.1.1 states that the technical assignment for R&D should take into account the interest of all possible consumers. Obviously, from the point of view of economic assessment of the costs of implementing consumer functions, basic, additional, etc., depending on the classification used, structural functional models and analytical reports generated within the framework of the value analysis significantly exceed the text tabular form for the presentation of the technical assignment, providing to the consumer with a more in-depth analysis of technical and economic indicators. The disadvantages of the expanded report in the field of economics, which is the value analysis report, is the inability to reflect such parameters mentioned in section 6.1.1 as the implementation of all mandatory requirements of standards and technical regulators applicable to these products. The second, the form of confirmation of conformity of products with these requirements provided by the legislation or certification, and the recommended stages of modernization, compliance with the requirements countries of intended export, etc. With respect to the technical assignment, subsections listed in the section requirements for the construction of content and presentation of technical assignment of GOST 15016, we will apply the classification methodology and divide them into two groups, where in the first group there will be technical assignment subsections that are displayed in structural functional models, and in the second those that are not displayed, i.e. are not taken into account in the value analysis. To the first group, the following subsections of the technical assignment can be attributed: technical requirements for the product, product composition, requirements and purpose, design requirements, requirements for electromagnetic compatibility, requirements for survivability and resistance to external influences, reliability requirements, requirements for ergonomics, habitability and technical aesthetics, requirements for operation, repair and storage and transportation. It becomes obvious to the observant listener that all the listed subsections, to one degree or another, fit into the classification of consumer functions used in the formulation of functions and the process of functional model formation. Of the listed elements of first group, the subsection product structure is displayed in the structural model. The remaining subsections are displayed in the functional model. The second group can include such subsections of technical assignment as standardization and unification requirements, cataloging requirements, manufacturability requirements, requirements for types of support, normative, technical, metrological, diagnostic, mathematical, and etc. Safety requirements, requirements for raw materials and PSIA materials, requirements for preservation, packaging, and labeling, requirements for training equipment, and special requirements. Referring again to the decomposition method of formation of structural model and the methods of formulating functions in the formation of functional model, as well as the exceptions of these methods and rules set out the video number 7, named Structural and Functional Models, Decomposition, Formulation of Functions of Block 1 of our training course, we can see that the above-mentioned subsections of the technical assignment can mainly be attributed to the specified exceptions, and are not included in structural and functional model. Such subsections as stages of the implementation of R&D, the procedure for the implementation and acceptance of the R&D, the procedure for the approval and approving of technical assignment for the R&D, and etc., related to the field of activity of specialists and the organization of business processes of approval and project managers, and can hardly to be attributed to the first or the second group, respectively, and not they are included in structural functional models and analytical reports. There are examples of the use of value analysis by project managers, but they will be considered in the block separately from the section of activities related to the formation of technical requirements and technical assignment in block 6 of the cost engineering training course. Subsection 6.2 Requirements for the design of technical assignment for R&D of section 6 named Requirements for the construction, content, presentation of technical assignment requires a separate consideration due to the presence of a direct connection with the advantages and disadvantages of the classic technical assignment compared to the extended technical assignment based on the application of value analysis techniques. The requirements for the design of technical assignment for R&D are set out in section 6.2 in sufficient detail. In particular, a reference is given to GOS 2.105 and GOS 2.301, containing in the frames of the design engineering with requirements for the design of diagrams, drawings, and etc. Such requirements for the formalization of technical assignment are due to the fact that, firstly, the technical assignment is an integral part of the contract for the implementation of the R&D, and secondly, the fact that the technical assignment is design engineering documentation and must be drawn up in accordance with the requirements of United System of Design Documentation, or USDD. Of course, these requirements do not apply the extended version of technical assignment. So, the extended version of technical assignment formed in accordance with the methodology of value analysis. However, it's not difficult to the issue and the extended version of technical assignment in practice of accordance with the above requirements, since it's also issued on A4 format sheets. Other section of GOST 15016-2016 devoted to the technical assignments for the part of the R&D. The technical assignment for R&D for development of PSIA, its abbreviation will be looked next. In next parts of our video. The technical assignments for the R&D and other types of work do not contain elements of interest to us that would not have already been mentioned above. Thus, we come to the conclusion that there is a significant similarity of approaches to the conducting of value analysis and the formation of technical assignment, which expressed in the use of identical or similar concepts given in GOST 15016-2016. Consequently, such elements of the value analysis as initial data for analysis, structural and functional models, and etc. can be fully used and used to prepare the technical specification for a product, component, or for structural part of a product. In accordance with the terminology used in GOST 15016-2016, a practical example of the use of value analysis data in the formation of technical specification for a component will be given in one of the videos of Block 2. Looking ahead, I will say that through the use of value analysis, an alternative technical assignment can be formed that has an expanded list of properties in terms of cost management at the early stages of the project. In my opinion, the best option to realize the maximum information security of project management is a joint use of basic classical technical requirements and technical assignment, together with analytical reporting formed on the basis of value analysis techniques. On the costengineering.ru website, the services section provides a description of services for training specialists, information of basic forms of technical requirements and technical assignments based on the value analysis data, description of an extended form of technical assignment containing extended analytical calculations, as well as description of one-time services for the formation of basic and extended forms of technical requirements and technical assignment for a product or its components. Subsections 6.1.5 Technical and economic requirements require separate considerations, since it allows to identify the scope of applicability of value analysis methods and the context of the list of requirements, the fulfillment of which will ensure the development of a product that meets the condition of economic feasibility of its creation according to the criterion efficiency, cost. See the wording in GOST 15016. Since most of the point in section 6.1.5 of the value analysis methodology cannot be applied, we will limit ourselves to listening only those points within which it's possible. In particular, of the value design engineering methods can be applied when assessing the cost of production, workshop and production costs at the early stages of development, including at the stage of technical proposal. With regard to life cycle costs, the value design engineering methods allow us to assess the effects of reducing the cost of producing a product or its component during the life cycle, provided that appropriate input data are available: production volume, life cycle, duration, etc. In addition, the value design engineering methods allow you to form a target acceptable shop cost of the product, as well as costs of implementing or embodying the product, consumer functions compared to the analogs, such as consumer functions. In this case, mean basic and additional options given either in the section technical requirements or in the annexes to the technical assignment, i.e., if we use marketing terminology, they are talking about an analog of option list. The results of comparing the list of possibilities of the value design engineering methods and the list of requirements given in the section Technical Economic Requirements confirm the positioning of the value design engineering as output data reports indicated above, not as a full-fledged replacement of the technical assignment in text form, but as an addition to the technical assignment, allowing to compensate for its shortcomings at the early stages of the project, characterized by a small volume initial data for technical and economic analysis. In addition, it can be concluded that the section of the technical assignment, technical economic requirements, there are no requirements for the effectiveness of the R&D requirements for the effectiveness of the R&D process. In particular, the effectiveness of the design documentation, design engineering documentation, development process, in accordance with the target value of the value production cost. There are no requirements for determining the degree of novelty of product relative to analogs. There are also no requirements for management accounting system and project management, which is in turn can be satisfied within the framework of the use of value design engineering techniques. During my working life in the aviation industry, I came across to the concept of a certification basis, i.e., a document that is formed during the development of a new aircraft by writing out items directly or indirectly related to the project object from the aviation rules. In the context of using the value analysis and value design engineering tools, I had an idea about the possibility of using the term functional basis when forming an alternative form of technical assignment, consisting of a kind of certification basis, consists of consumer functions written out technical requirements of a technical assignment, on the basis of which functional and structural models can be formed. Thus, in our case, the role of aviation rules in the technical requirements or technical assignment at the early stages of the project. The difference from the case of aviation rules, firstly, is that we write our full formulations and formulation of functional from the technical requirements or technical assignment in accordance with the formulation methodology adopted in the value analysis. Secondly, the content of aviation can be assumed to be conditionally constant for the period of project implementation and other content of technical requirements. And then technical assignments, it can change significantly, especially in the early stages of the project. It's the concept of functional basis and value analysis and the value design engineering that will be partially devoted to further exposition. For further exposition, it's necessary to introduce the concept of a textual functional basis, since within the framework of Block 2 of our course we mainly consider the elements of value design engineering, i.e. the methods directly used in the process of supporting the development of the design engineering. Then, when considering the possibilities of using the value design engineering in the process of forming the technical assignment, it would be logical to assume that the text functional basis will be based on data from the section of technical assignment named technical requirements, especially since, in fact, this section is similar content to the design engineering document technical requirements, which precedes the development of the technical assignment and is formed at the early stages of the project implementation. Accordingly, when forming a test functional basis section to the technical assignment that are not directly related to the process of developing design documentation directly, i.e. all sections except the section of technical requirements will either be reflected in less detail than it should be in the technical assignment according to the GOST 15016 or completely excluded. In particular, the text functional basis will not include such sections of the technical assignment as maintenance and repair system, requirements for patent purity, requirements for unification and standardization, and etc. In the absence of the one types of resources listed on the slide, instead of an expanded functional basis that includes such sections as name and scope, basis for development, purpose of development, a standard functional basis is formed in tabular form. An example of extended functional basis and a standard functional basis of varying degrees of abstraction will be given below. The slide advanced and standard functional basis presents the types of functional basis that can be formed depending on the requirements for analytical support of product development process. The differences between the extended and standard functional basis can primarily be attributed to the difference in the formats of their formation and the resulting difference in labor intensity. It's logical that it's easier to fill out the standard tabular form of the standard functional basis than to form a full-fledged text document with sections similar in degree of semantic content with technical assignment. The second difference follows from the first and consists in the formation of different reserve for the subsequent formation of technical assignment based on data of the functional basis. Indeed, in sections of the extended text of functional basis are completely similar in degree of detail to the sections name and scope, basis for development, purpose and and of development of technical assignment, and can either serve as a foundation for the formation of technical assignment at the early stages of the project, or can be used to verify technical assignment during their parallel development. In the case of standard table of functional basis, we have information that fully meets the requirements for the formulation of functions for functional model, since these formulations comply with the rules for the formulation of functions and classification of functions, which we considered in issue number 7 of course engineering training course. The formulation based on the standard table of functional basis of the section technical assignment of the technical assignment, technical requirements of the technical assignment document. It's possible only with a reservation for the additional complexity associated with the need to expand the formulations of functions to the textual form characteristics of the technical assignment and the extended functional basis. As an example of extended functional basis, we will consider textual functional basis for the development of a mountain bike, or MTB. In this text functional basis, there are such sections as name and scope, basis for development, purpose and of development, technical requirements, and economic indicators. Other sections of the development of a mountain bike are not included in the text functional basis for the reasons described above. In the section name and scope of application, the designation of the bicycle is given in accordance with the GOST 31 741. The differences from an annex are listed. The terms of work indicated in the name of the developer company, etc. The sections basis for development and purpose of development indicate typical formulations for the design engineering object. This is followed by section 4 technical requirements, section 4.1 product composition and requirements for a bicycle, reflects the aggregate and system composition of a bicycle, and in the case of using terminology of the value analysis, an abstract structural model of a top-level bicycle is given, on the basis of which the following subsections of section 4.1 are entitled. Subsection 4.1.1 provides a general scheme for describing the main parameters and characteristics of bicycle designs in an abbreviated form. Since the formation of a complete description doesn't make sense in the context of the task of forming an alternative form of technical assignment. The following subsections from 4.1.2 to 4.1.11, as indicated above, fully corresponds to the abstract structural model of a top-level bicycle. Top-level abstract structural model of a bicycle. The section economic indicators of the extended functional basis formed by the analogy with the section economic indicators of the technical assignment according to GOST 15.016. In my experience, contains only general phrases that the target price and direct costs of a product should be determined during the implementation of the project in the process of interaction with the supplier. In addition, often of these sections there is a similar general phrase about the need to estimate the costs of the product. It will be shown below that in the case of the formation of an alternative form of technical assignment, this section can be supplemented with the target indicators of direct costs determined using the methods of the value analysis. Let's consider a standard table of functional basis of various degrees of abstraction using the example of the object analysis already familiar to us. A bolt, a bushing, housing, or front wheel, and the bicycle, the front wheel assembly and the bicycle assembly. The front of the standard functional basis is standardized. In the upper left corner of the form, there is a block displaying the status of the part in terms of development status, namely type of design documentation. For example, project to design documentation may be included in this in this block. Development stage, the next block, uh, that may include a technical proposal, draft design, uh, and technical design for the project design documentation stage. Design documentation for prototype, serial or single production for the work and design documentation stage, and work stage. It should be noted right away that the totality of possible data for filling this block is fully reflected to the GOST 2.103, named United System of Design Documentation Stages of Designing. The principle of filling in this block the above mentioned objects of analysis had the following logic. For the most abstract degrees of consideration, the status project design documentation with the corresponding stages and stages of work is affixed, and for the object of analysis, Buchenhausen and Bolt, the status working design documentation is also affixed with the corresponding stages and stages of work. I think the logic here is clear. At an earlier stage of product design documentation, more abstract product models are formed. At later stages of work in design documentation, small parts are designed, which includes the bolt and Buchenhausen. The next block of the standard form contains information about the primary application by analogy with a graph of the standard United System of Design Documentation format for drawings, i.e. information about the upper level details that include the object of analysis. The fill-in rule in this case is simple. In order to avoid uncertainty and upper level detail corresponding to the subsections of the section technical requirements of the technical assignment is entered to the primary application field. For example, for a ball that is located in the handlebar and column is entered to this field. Front wheel is entered for the Buchenhausen. Bicycle is entered for the front wheel for the upper level object of analysis. This field is not filled in. Regarding filling in the component and model type fields, I believe no comments are required. The logic of filling the columns function number, function type, and function description fully correspond to the filling logic described for functional model in the issues number 7 and number 8 of our training course. The column initial data for the formulation of the functional function or design documentation or technical assignment is filled in according to which source of information was used, and the formulation of function in the column function description. Of course, in accordance with the United System of Design Documentation, the technical assignment is also a design documentation. So the use of the alternative design documentation or technical assignment at first glance seems absurd. However, in this case, when we put down technical assignment, it means that the description of the function is reflected at the current stage of the project only the technical assignment, and it's already reflected in the design, i.e. the function is embedded in the design in accordance with the drawings of 3D model design documentation as affixed. Therefore, the fill-in rule can be formulated as follows. If the information for the formulation of functions is reflected only in drawing the strength calculation report, for example, manufacturing tolerance, description of power work, placement, then design documentation as affixed if the information is reflected on a technical assignment in the form of one item in the section technical requirements. Then technical assignment is put in the field. If the information about the function is contained in both the design documentation and the technical assignment, then design documentation is put in the field, since the design documentation is a more preferable source of information compared to the technical assignment, due to the lower degree of abstraction. As we can see, three of the four models are mixed from the point of view of filling the column initial data for the formulation of function or design documentation or technical assignment. This situation is typical. In the model of the upper level abstraction, only technical assignment is included as a source of information, which is also a typical case. The fields of the column technical assignment item are filled in accordance to the information in the column initial data for the formulation of function, design documentation, or technical assignment, i.e. Either the item technological assignment is which the function is mentioned is put down, or a dash is put down. The comment column, as a rule, contains the name of the item of technical assignment and other necessary information according to the analyst. When forming the extended and standard functional basis, it is highly recommended to preserve the structure name and the numbering of section of aggregates and system of the object of analysis given in technical assignment, i.e. in the section requirements for the frame in the technical assignment has number 4.1.2, then consequently it should have the same numbering and the name and the both and the extended and standard functional basis. In terms of the extended functional basis, which has much more in common with the text form of technical assignment, according to GOST 15016, than the standard functional basis, and in fact is its stripped down version. It's difficult to add something different from the methodology for generating initial data for the technical assignment, set out in GOST 15016 or BS series standards. With regard to the standard functional basis, the situation is significantly different. Most of the items in the section technical requirements of the text technical assignment according to GOST 15016, which at first glance is the main source of initial data for the formation of a standard functional basis, doesn't comply with the rules for the formulation of functions announced in issue number 7, decomposition of the object of analysis, formulation of functions of our training course, i.e. do not allow to formulate any functions on its basis. Thus, the actual sources of information for the formation of alternative form of technical assignment are the first, competence of employees of the design engineering department, the second, design documentation, design engineering documentation of analytics of the previous generation, and the third, information about analytics of competing companies. This list can be continued, but already from the first 3 points, it's clear that it's actually similar to the list of initial data for the formation of structural and functional model, which we considered in issue number 8, structural and functional models of the object of analysis, classification, examples. Thus, we come to the conclusion that from an informational point of view, the standard functional basis, along with structural and functional model, isn't only an alternative form of design engineering documentation representation that allows generating analytical reports, but also a form of representation that requires additional initial data to be generated, therefore presenting the user with a larger volume compared to design engineering documentation, technical and economic information. As an example, if it's impossible to use most of the information provided to the technical assignment to form a standard functional basis, consider the individual paragraphs of the section technical requirements of the extended text functional basis. The wording of these paragraphs is completely similar to a technical assignment, according to GOS 15016. In subsection 4.1 of GOS 15016 of section technical requirements, information about the main units and systems of the product is displayed. Thus, the technical specification for the product gives us only information for the formation of an upper-level structural model and gives absolutely no information for the formation of structural model for aggregates and systems. Thus, the technical assignment section on the product answers the question we posed earlier: how many technical assignments should there be? In our case, there are 11 aggregates and systems, and taking into account the total technical assignment for the product, there will be at least 12 technical assignments. Respectively, information for the formation of structural model aggregates and system will be set out in them. Nevertheless, such an approach to the composition of technical assignment doesn't solve the problem formation of structural model of the middle and lower levels, including complete structural models. Simply put, it's possible to create drawings and 3D layouts of parts and assembly units of complete structural and complete functional model, but unfortunately it's impossible on the basis of technical assignment, since in any case they relate to abstract structural and abstract functional model of either the upper or middle degrees of abstraction. The situation is similar with the formation of functional models. Consider the requirements for the frame. Consider the requirements for the handlebar and column. I think it makes no sense to read the other paragraphs of the section of technical assignment in order to understand. 99% of them have a formulation from the middle to the upper degree of abstraction. In medium level technical specification for bicycle units and systems, the situation will be similar. Consequently, the entire set of technical assignments for the product and its aggregates and system isn't a sufficient source of information for analysis, including the formation of structural and functional models and analytical reports at all levels of abstraction. i.e., we come to the conclusion that we confirm the assumption that's necessary to form an additional pool of technical and economic input data or initial data in the process of applying cost design techniques or value design engineering. The features of the formation of extended and standard functional bases were announced above, in connection with which we will consider the formation of structural and functional model in the context of alternative technical assignment. In terms of the formation of the structural model based on the technical assignment according to GOS 15016 or on the basis of the educational technical assignment, in the first approximation everything is relatively simple, i.e., the structural model will correspond to the structure indicated in our case in the section 4.1 product composition and requirements for the bicycle of the extended functional basis. In the case of functional model formation, everything turns out to be somewhat more complicated. The first problem we face is that not each section describing the functions of the component can be formalized, i.e., formulated in accordance with the rules of the formulation of functions in the value analysis. For example, if we consider the frame, which is the most complex component from the point of view of describing the requirements for it, then it's completely unclear how paragraph 4.1.2.14 concerning permissible protrusions on a frame can be briefly formulated in the form of a function. In particular, the problem lies in the fact that if you formulate this section as excludes the presence of protrusions, then taking into account the fact that there are many protruding elements and they are addition distributed among various elements in the frame, we're not able to estimate the costs of elimination in any other way than by considering each of them separately. However, taking into account the degree of abstraction specified in the section 4.1, product composition requirements for the bike, such an option doesn't suit us, since we need to designate the absence of protrusions on the frame with one function. Otherwise, the functional model will turn out to be too cumbersome. The way out of this situation is to use this simplified classification of functions to form an alternative form of technical assignment. To form the abstract structural and structured abstract functional model of technical assignment, we use a special classification of functions formed on the basis of the existing complete classification used in the value analysis and value design engineering, taking into account the exclusion from the out certain groups of functions that do not relate to the content of the technical assignment. In accordance with the GOST 15016, the list of functions excluded from the full classification discussed in the issue number 7, decomposition of object of analysis, the formulation of functions, will be given below. In addition, it should be borne in mind that when forming the abstract structural and abstract functional model of technical assignment, we will face the problem that a number of functions described in the technical assignment fall under the exceptions described in issue number 7, decomposition of the object of analysis, formulation of functions. A special classification of functions form in the basis of the basic classification considered by us in issue number 7 is formed by excluding from its functions that are not related to the content and technical assignment in accordance with GOST 15016. In particular, there are 3 types of functions that make up block of special functions, since all functions of the basic classification, in particular the functions of the block of general functions, namely consumer and technical and operational functions, can be used in the formation of technical abstract functional model of technical assignment. Generally speaking, the approximate distribution of the functions of the general function block by section of the technical assignment was given in the summary table of classification of functions at the column formulation and the technical assignment for a component product use in practice. For 2 and 3 types of functions of special functions block, possible section of their mention in the technical assignment are also indicated in the specified column of the summary table. However, in this instruction we are talking about the formation of a complete technical assignment for the product in accordance with the GOST of 15016 and not about for the formation of alternative technical assignment. The formation of an alternative form of technical assignment can be performed for 2 options. Alternative technical assignment for the product as a whole and alternative technical assignment for the product component. Formation of an alternative technical assignment for the product as a whole. In this case, we are talking about the formation of an expanded and standard functions functional basis for the bicycle assembly, which we have already discussed above, as well as structural and functional model and analytical reporting for this product, which we will consider below. The number of abstract structural model elements in this case will correspond in the first approximation to the number of blocks of section technical requirements corresponding to the design composition of the product. As a rule, the number of partition does not exceed 15-20, so as in a case with the method of using cost drivers, we avoid excessive bulkiness of abstract structure and abstract functional model. As we mentioned above, in the case of technical assignment for bicycle, the number of blocks of the section technical requirements is 11. Respectively, a similar number of blocks of the section technical assignment is included in the extended functional basis. Formation of an alternative technical specification for a product component. In this case, we are talking about the formation of a standard functional basis for the bushing, housing, and bolt, which have already been considered by us above, as well as structural functional model and analytical reporting for these components, which will be considered by us below. The format and initial data for the filling out the extended bike abstract structural model, which we will take as a basis for forming an alternative form of technical assignment, have already been discussed in issue number 7 and number 8. So, I will not dwell on them in detail. The composition of the structural model of the bicycle from issues number 7 and 8 fully corresponds to the composition of a considered extended functional basis for the bicycle assembly, and differ from the examples discussed in issues number 7 and 8, and the carriers of the functions front wheel and rear wheel are combined into the carrier wheels. In addition, added a new carrier function are the equipment, including the flaps, bell, footboard, and etc., corresponding to the section 4.1.11 of the extended functional basis of the same name. Accordingly, if it's necessary to conduct an analysis of a lower level abstraction, for example, in the case of the formation of an alternative technical assignment for a chain or front wheel, the structural model elements will also correspond to the elements of the section technical requirements of the extended functional basis for chain or front wheel. I will focus on filling out the abstract functional model in more detail, due to the fact that filling in some fields of the standard abstract functional model form will differ to varying degrees from the example discussed in the issues number 7 and 8. In the component field, the value bicycle will be changed to mountain bike model 585. Accordingly to the model type field remains unchanged, i.e. it contains the value abstract functional model. Since in the issue I would like to present basic analytics for the abstract structural model of a bicycle and its individual aggregates filling the individual fields of standard abstract structural model form will be performed without justification. In particular, we are talking about the column block, applied methods for determining the related significant functions. Looking ahead, I will say that determining the significance of the abstract functional and complete functional models functions, it perhaps the most important and time-consuming stage of their formation. In this regard, a separate video of Block 1 entitled Functional Model Methods for Assessing the Significance of Functions, without delving into the topic of determining the significance, I note that functional model of various degrees of abstraction correspond to various methods for determining the significance of function. Respectively, the heading of the column block, applied methods for determining the related significance of functions for the abstract functional model of a bicycle and its aggregates, will contain the designation of various techniques from M1 to M15. Since I use about 15 techniques in my practice, which in my opinion is quite sufficient to cover the entire range of degrees of abstraction of functional models. The numbering of the methods within the classification is carried out in such a way that the methods suitable for more abstract models begin with M1, M2, M3, and the more methods suitable for complete functional models, both, for example, or models close to complete, Buschenhausen, for example, have a designation M12, M13, M14, M15 are designated techniques that can be used for functional model of low degree of abstraction or complete functional model. With regard to the initial data for the formation of an alternative form of technical assignment, the following remarks should be made. The composition of the top-level abstract structural models for the bicycle analysis object will fully correspond to the structure of the extended functional basis, so in the case we do not face the question of the need for additional initial data. In the case of structural models of bicycle units, there is a need for additional initial data because the example from the concept of the sections frame, handlebar and column, wheels, and etc. It's impossible to get an idea for the design of the unit or system. Thus, we come to the conclusion that formation of an alternative form of technical assignment at any level of abstraction except the upper one requires additional initial data in the form of either separate technical specification for the analyzed unit or system or additional design engineering documentation in the form of drawings or 3D models and layouts. The design engineering documentation used can be both design and operational, depending on the stage of project implementation. We borrow the formulation of the main function in the primary field from the section Purpose of Development Technical Assignment with an amendment to the rules of the formation of functions in the value analysis, which we reviewed in issue number 7. I.e., at the beginning of the sentence, we insert the standard phrase, provide an opportunity. Since the bicycle is the highest possible one at the level of abstraction of considering the object of analysis, then as a first approximation we can start filling and form the column function carrier, i.e. from right to left, i.e. actually transfer all 10 function carriers from the structural model to the functional one. Next, we need to decide which the methods of determining the significance we plan to use in the first approximation. As already mentioned above, for functional models of the highest degree of abstraction, the most suitable methods are M1, M2, and M3, since the application of these methods requires a relatively small amount of initial data and human resources. In addition, for the consumer goods, which include the bicycle, the M4, M5, and M6 methods can be applied. The issue number 11, devoted to the methods for determining the significance of functions, the M1 technique, will be considered in a little more detail, but its main feature should be mentioned now. Simply put, the M1 methodology in the context of functional and cost analysis is an analog of concept proposed by Polygraph, take everything divide, i.e. dividing significance, equally among all carriers. Such a principle in relation to real function models, to put it mildly, it's not entirely correct. However, it plays an important role of the nominal principle, which is designated and not recommended for use, i.e. if someone comes to mind to use the M1 methodology in practice, then pointing to it to the table of principle of significance distribution should warn to the cost and engineer from such an action. Thus, in accordance with the description of M2, M3 M6 methods, we assign one abstract function to each element of the structural model consisting of 10 elements. The significance, the newly formulated functions in the first approximation, is given to the column block applied methods for determining the relative significance of functions of the tabular functional model. The stage of calculating the given expert assessment of significance in this case is omitted and will be discussed in more detail in issue number 11, as well as in issues devoted to practical cases of a working group of experts and determining the significance of function using neural networks. Then, by multiplying the average value of significance, we fill in the column expert evaluation of direct costs for functions. For the object of analysis, bicycle and front wheel for the total amount of direct costs for the technical assignments for the object of analysis. As we can see, for the object of analysis bicycle, one function carrier corresponds to one function, unlike the object of analysis front wheel, where one function corresponds to several media. The principle of filling in the column function carrier has already been outlined in issues number 7 and 8. If it briefly formulated, then this column contains all function carriers related to the performance of the function. These circumstances suggest a comparison of the values of direct costs for functions for the object of analysis, bicycle and front wheel. In the column expert evaluate of direct cost for function of the abstract functional model calculated in accordance with the average value of m rubles, and the column technical commercial proposal or TCP for functional carrier of abstract structural model, in which the actual prices for purchased products from the technical commercial proposal are indicated. The first thing I would like to draw the listeners' attention that on the technical commercial proposal column, the values of direct costs are actual, and the expert evaluate of direct costs for function based on technical commercial proposal column are expert, i.e. set use and methods for determining significance for abstract functional model. Let's consider the most significant deviations, which are deviations for functional carriers, frame, and other equipment. The deviation in the frame is obviously due to the fact that this is only component that the company produces independently. So, the supplier's margin is not included in the amount of direct cost for the frame, which is why direct costs for the frame are significantly lower than for other components that are purchased products, which are, with regard to the carrier or the other equipment functions, is quite difficult to comment on the deviation due to the high degree of abstraction of consideration, i.e. since this abstract structural model doesn't provide a list of other equipment, it's impossible to give any comment. In this case, we either carry out additional analytical work on the decomposition of the other equipment function carrier, or we are satisfied with the result we received. Since the function carrier in questions isn't most interesting for the terms of potential for reducing direct costs for a cost engineer, since obviously it consists of several purchased products, and the only option for reducing direct costs in this case will be the search for alternative suppliers, which is a direct responsibility not for a cost engineer but for buyers. The slight discrepancy for the other functions carriers of the object of analysis, bicycle, isn't critical for this level of abstraction, especially in conditions of information scarcity and the initial stages of the project, and rather serves as confirmation of the calculated values of average relative significance for the functions. At the same time, it suggests that rationality of introducing stricter requirements for the formulation of functions and linking them to the availability of design engineering documentation and the commercial offer, indicating the amount of direct cost for the function carrier, i.e. to the idea of the possibility of forming analytical reports of the value analysis at a high level abstraction, devoid of disadvantages associated with the presence of errors caused by the use of expert methods and the excess of the number of functions over the number of carriers. Exceeding the number of functions over the number of carriers is a normal phenomenon. Moreover, it's so indirect confirmation that an abstract functional model has a high degree of reliability, i.e. at the most close to the complete structural model. But the problem lies in the fact that the real number of functions in 99% of cases cannot be correctly described without its decomposition, which we will witness in the process of determining the relative significance of the front wheel function carriers. For the object of analysis front wheel, we do not have an opportunity to conduct a significance discrepancy analysis similar to the one we conducted for the object of analysis bicycle on the previous slide, because when formulating functions, the level of abstraction in the process of formulating functions was reduced. In particular, the strength and performance characteristics of the object of analysis were considered in this abstract functional model, i.e. technical and operational functions were introduced in the functional model in addition to the consumer ons. If you formed the abstract functional model of the front wheel having a separate technical specification for the front wheel, designed according to the GOST 15016, then it would be possible to apply the principles of function formulation similar to those that we use for the object of analysis bicycle. And one function carrier would also correspond to one function. Listeners familiar with the design engineering process know that, as a rule, from the technical assignment for the product and its main units and systems. Thus, we come to the conclusion that in top level of abstract functional models, such as bicycle as a rule, there are no functions other than consumer ones. For abstract functional model of the level of systems and aggregates, as well as abstract functional model of a lower level, the presence of both consumer and technical operational functions is characteristic. Indeed, if we compare the contents of the columns functional type for the object of analysis, bicycle and front wheel, we can see that in the first case only consumer functions, base and additional ADT, present the abstract functional model, and in the second, in addition to consumer ones, technical and operational, main technical, MT, and main operational, MOP. A few words should be said about filling the ERP column or the commercial data column block of the bicycle and front wheel of abstract structural model. For both abstract structural models, the mechanism for filling this column will be the same. The logic of filling in this column of the form as follows. Data unloading from the ERP system is available only for components of the products of its own production. Thus, in our example, we are dealing with a bicycle manufacturer who independently produces only the bicycle frame, and all other components are purchased products. Accordingly, the value of 9,153 rubles, conventional monetary units, should be automatically extended to the adjustment column Technical Commercial Proposal, or TCP, which is what we see as our bike abstract structural model. For the front wheel analysis object, respectively, the ERP column doesn't contain any values. The principle of filling in the column of expert value of target direct cost for functional carrier can also be attributed to the differences of two abstract structural models considered by us. Abstract structural model of the bicycle and abstract structural model of the front wheel. Filling in these columns is performed after filling out the abstract functional model form, because in value design engineering the target direct costs for components are determined as a first approximation based on the average value of the expert assessment of functional significance. See column M average of abstract functional model. Therefore, for the abstract functional model of the object of analysis bicycle, due to the fact that one carrier corresponds to the one function, filling in the column expert value of target direct costs for functional carrier has a simpler logic. Step 1. A proportion is made between the current target value of the total direct cost for the product and the current value of the total direct cost for the product according to Technical Commercial Proposal. In this case, the ratio is 0.71. Step 2. The costs of abstract functional model functions from the column expert value of direct cost for functions are multiplied by 0.71, as a result of which we get a target value for the cost for the functions and column expert values of target direct costs for the functions of abstract functional model. Step 3. The corresponding elements of the abstract structural model in the column expert value of target direct costs for functional carriers are assigned the target cost for functions defined in the column expert value of direct costs for functions. Abstract functional model and the second step of the calculation. For the front wheel abstract structural model, the calculation logic is similar, but has an additional stage due to the fact that several function carriers correspond to one functions of the abstract functional model out of front wheel and not one of the abstract functional model of a bicycle. i.e., the term corresponds actually means that several carriers participate in the performance of this function, which is characteristic in particular for technical and operational functions that are contained in the abstract functional model of the front wheel. Thus, after performing three similar calculation steps, it's necessary to determine the costs for each carrier of functions in the column expert evaluate of target cost, direct cost for functional carriers of abstract structural model by adding the costs of functions from the column expert evaluate of target direct cost for functions of abstract functional model corresponding to the function carriers. For example, the carrier of the bushing housing marked HFWB functions carrier functions is used to implement two functions, F1 to form visual effects related to the housing of front wheel bushing, and F9 to transfer the load from the suspension fork to the rolling surface of the wheel, and F10 to transfer of the locking force to the brake disc rotor during braking to the rolling surface. Okay, it's not two functions, it's three functions, and the significance of these three functions in accordance with the abstract functional model of the front wheel is O.108, O.011, and O.069. Respectively, therefore, the significance of the function carrier of the HFWB functions is the O.108 plus O.11 plus O.069, it's equal O.119. Similarly, the significance of all other carriers of functions from FC2 to FC10 is determined. The total significance of all the functions carriers will be greater than 1, but the proportion we need can be made up. In my practice for beauty, I always perform a reduction to the one of the reporting tables, and all the values of relative significance always add up to 1. The reduction to 1 is also convenient in practical terms, since the appearance of thousands of 10 or 10 thousandths at the bottom or top of the table is usually noticeable. Therefore, an error has been made somewhere and it's necessary to double check. Then, the significance of each carrier is multiplied by the total target cost of all carriers. In this case, it's 8,974 rubles or conventional monetary units. The application of the above methodology for a bicycle and front wheel allows us to obtain the values of targeted direct costs, see column expert evaluate of target direct cost for function carrier, calculated based on the values of the related significance of the functions corresponding to function carriers, calculated by applying expert techniques. As we can see, for some components, see highlight in red and yellow, deviations for the of the target and current values of the front wheel function carriers can reach from a significant value. Function carrier number 3, for example, is bearing deviation by an order of magnitude. Such an absurd amount of deviation indicates the presence of a fundamental error in reasoning, i.e., in this case, that there is no critical number of functions in the functional model that allow distributing the cost of the function carriers correctly. In fact, our proposed model of the front wheel is too simple, which leads to absurd results. If it's expanded by increasing the number of functions, the results will begin to level out. In particular, such a value of deviation obtained by assigning relative significance to the functions carriers and direct costs calculated on this basis confirms the thesis expressed in issue number 8 that reliable values of relative significance for the functions carriers of the abstract functional model functions of the upper and middle levels in most cases cannot be achieved by direct application of expert techniques, which in this case it took place and required the introduction of additional restrictions when working with abstract functional model of the upper and middle levels. This limitation of the applicability of expert techniques will be discussed in more detail in issue number 11. In case of forming a table with discrepancies of values from the columns technical commercial proposal for the function carriers, abstract structural model and expert evaluation of direct cost of functions, similar to the one we have already formed for bicycle, we also encounter unacceptable abstract values of functions of discrepancies that have reasons similar to those outlined below. Moreover, in the slide with the discrepancies of significance for the front wheel, we see much larger discrepancies between the actual cost and the costs determined by the expert method based on the magnitude of the significance and the function carriers. Similar absurd deviations are associated with the individual effect characteristics of mid-level abstract functional model. Indeed, for the lower-level abstract functional model and complete functional model, significant discrepancies between the calculated and actual values are impossible. Firstly, due to the detailed and the time-consuming consideration for each structural element of the consuming element of, of each wall, chamfer, roughness, and etc. And secondly, due to the approximately the same level of structural complexity of function carriers. There are also no such significant discrepancies for the upper-level abstract structural model, see bicycle, due to the fact that all elements in the first approximation are equal in terms to the level of constructive complexity of the number of functions that can be assigned to them. The slide shows two most common effects that lead to discrepancies in the estimated and actual values of function carrier costs. The first effect is the combination in structural model of functions carriers of different levels of structural complexity. For example, in the case of front wheel, spokes, adapters, rime, flipper, brake disc can be attributed to conditionally simple spokes, adapters, rime, flipper, brake disc, and to conditionally complex such as bushing housing. The second effect is the presence in an abstract structural model containing structurally complex products such as the bushing housing of standard products with relatively low costs. In this case, a bearing and a flipper for which we have the greatest deviations. Usually, such deviations are absurd for hinges, handles, bolts, and etc. Accidentally caught in the middle level of abstraction, whereas the greatest efficiency of their consideration can be provided at low levels, at the level of the complete structural model. The only more or less effective method in this case is the decomposition of most structurally complex function carriers of structural model in order to equalize the significance. However, in this case, the front wheel, this approach not applicable, since the bushing housing can only be decomposed to the complete structural model level, since it's not an assembly unit, but a part. In this case, the most effective method is a complete decomposition, i.e. a separate consideration of each of function carriers of the front wheel. Thus, for the upper level abstract structural model, the relative importance of its function carrier and therefore a target value of direct cost for them can be determined by induction from the particular to the general, i.e. at the sum of the significance of its constituent elements of a lower level abstraction close to a complete structural model and complete functional model, and the second by applying the principle of forming artificial restrictions, in particular matching no more than one function to one carrier, as well as other restrictions that will be discussed below. With regard to the adapted abstract functional and abstract structural model, which I mentioned in issue number 8, and in a description of which it was indicated that their use allows us to dispense with the formation of complete structural model and lower level functional model and the first approximation, we can say that they are more of an application to the method of factor research used partially in isolation and final abstract structural and abstract functional model mentioned in this case, consisting of 15 or 20 elements and required mainly for visualization, since the cost drivers as the presentation cannot hang in the air, i.e. they cannot be presented to the management separately from the entire structure without specifying the carrier of functions to which they are related. In addition, when forming an adapted abstract structural and abstract functional model, it's necessary to adhere to the restriction one carrier, one function, as well as additional restrictions related to the availability of technical and economic information, which will be discussed below. At first glance, the results obtained for the front wheel suggest value analysis. Generally speaking, it's a rather dubious tool that can produce absurd results, the formation of which is associated with significant labor costs. This is not quite true. Value analysis is a tool that has significant limitations of applicability depending on the level of abstraction of analysis object. For the lower level of abstraction of consideration, we're talking about a complete structural functional model of Bolt and abstract functional structural model of the lower level abstraction of Buschenhausen. These limitations were considered by us in issues number 7 and 8 and were expressed mainly the rules for the formulation of functions and the formation of structural functional models related to the features of technological process of manufacturing, object of analysis, its strength and performance characteristics. At the upper level abstraction, at the bicycle example, the constraints are of a different nature and associated with the presence of a strict correspondence of individual abstract functions of technical economic characteristics. Consequently, the zone of average degrees of abstraction of consideration, in accordance with the logic of our reasoning, remains the most problematic from the point of view of possibility of its analysis. However, one of the methods of getting out of the situation is the formation of quasi-abstract structures at the lower level of abstraction. This is exactly the case when we create technical assignment not only for bicycle, but also technical assignment for each of its individual aggregates. Thus, we can provide each of these components with technical and economic information, i.e., in fact, to obtain technical commercial proposal of the calculation for each of the components and thus conduct an analysis using the methodology for the upper degrees of abstraction of consideration, some elements of which we have already considered, and some will be outlined below. The two examples above of abstract structural and functional models are examples of two different approaches to the formulation of functions. In particular, 10 carrier of functions of the object of analysis, bicycle, correspond to 10 functions, and 10 carriers of functions of the object of analysis, front wheel, correspond to 11 functions. The discrepancy between the number of function carriers and the number of functions may be more significant, as can be seen from the example of Bolt and the Sleevehausen or Buschenhausen, for which our ratio was 7:16 and 14:33 respectively, i.e. for full and close to complete functional model, the number of function carriers is about 2.5 times less than the number of functions. These approaches were not introduced in issue number 7, dedicated to the decomposition of the object of analysis and the rules for the formulation of functions, Because firstly, they affect a wider area of factors affecting affecting the formulation of a function than the area indicated in issue number 7 and includes only general principle of formulation. Secondly, they are directly related to cost design engineering, in particular due to the fact that I would like to introduce them specifically in the context of technical assignments and value design engineering, i.e. in block 3 of our training course. I will formulate the definitions of these two approaches in the traditional text form, but will present them in the form of a comparative table and comment on its contents. So, the basic difference between complex formulation and isolated or direct formulation, the principles of which were outlined in the issue number 7, it's need to evaluate such criteria as the presence of an unambiguous binding of the formulation of functional model functions to the fact of the availability of design engineering documentation and commercial information, such as technical and commercial proposals for function carriers, for example. Thus, we need to expand the principle of formation of artificial constraints for upper and middle level abstract functional model. The next rule: one carrier of function equal one function. Given the previous slide, taking into account the requirements of linking functional model functions not only to design engineering documentation, but also technical and economic information, i.e. the consequence of basic differences between the complex formulation and the isolated one is the formation of a constraint in the form of principle. One function carriers equal one function equal one price. In addition, the differences between the complex formulation and the isolated formulation include application of complex and isolated formulation for functional model of various levels of abstraction, complex for upper and middle, isolated for level close to complete functional model. Application by specialist of various fields indicated in the division column. Application in various areas of project work indicated in the column area of project work. The advantages and disadvantages of both methods of formulation are also given in the corresponding columns of the table. The simplest example of a complex formulation is the following practical case. We are developing a technical specification for a bicycle which can be decomposed at the upper level abstraction into 10 carriers of function. For each of the 10 carriers of function, we have dimensional drawings or 3D models with all the necessary data. A commercial offer was received for each of the function carriers with a price corresponding to the decomposition level. An abstract function describing its functionality is formulated for each of the function carriers. So, we have the next 10 function carriers with dimensional drawings and models. The second, 10 commercial offers for each of the components. And the third, 10 formulator functions. Thus, in the case of applying the method of complex formulation, the principle of one carrier equal one function equal one price takes place. Accordingly to the example of independent formulation is a practical case with the design of the working design documentation of for a bolt front wheel bushing housing, where the number of function model functions is several times greater than the number of function model function carriers, and the availability of design documentation and commercial proposals doesn't correspond to the level of abstraction of structural model and functional model, which accordingly requires the use of expert evaluation, or EE. Expressed primarily in application of methods for determining the significance of functions that were comparing the results of their application, as we can see by the example of the bicycle functional model, and technical and commercial proposals for the elements of the bicycle structural model. It gives sometimes significant discrepancies between the actual and expert assessment of the significance of function and their carriers, and therefore into the error. Firstly, in the process of determining the target value of direct costs for the function carriers. Secondly, in the process of comparing the value of relative importance and relative direct costs in analytical reports, an example of which will be discussed below. A reservation should be made about the theoretical possibility of bringing the level of reliability of analytical reporting of structural and functional models formed by the method of independent formulation of functions to the level of reliability of analytical reporting of structural and functional models formed by the method of a complex formulation of functions, subject to the availability of the necessary design engineering documentation. The tools for such a transformation, i.e., in fact, to obtain the necessary economic information are: first, the presence of in-shop technical process, the corresponding shop calculations. Second, analysis using product cost management software. In fact, using of any of these tools, of these two tools, allows us to obtain economic information suitable for increasing the level of reliability of analytical reporting on abstract structural and functional model of a wide range of abstraction levels, with the exception of abstract structural and functional models of lower level of abstraction up to complete structural and functional models for many areas of activity. In particular, the formation of analytical reports for management, design engineering at the early stages of the project, and participation in commercial negotiations, this is quite enough. According to the results of the formation of an alternative form for technical assignment for a bicycle and its aggregates, two groups of effects can be distinguished. The first, effects within the framework of the technical assignment format according to the GOST 15016, and the second, effects within the format of an alternative form of technical assignment. If we classify the effects within the framework of the technical assignment format according to GOST 15016 into local and system, as it down in the table on the slide, then the conditional system effects include the formation of an end-to-end development system that allows synchronizing the technical and economic parameters of the main units and systems of the product specified in the technical specification with pre-design, design, and working design documentation. Thus, the use of both of these groups of effects is one of the main conditions for the integration of the value design engineer system into the business processes of product design engineering. The effects within the framework of technical assignment are format according to GOST 15016. The first, the possibility of specifying the relative target value of direct cost for the main units and systems of the product, as well as their components in the section Economic Indicators of Technical Assignment according to GOST 15016. In the case of analytical reporting using value analysis methods, this section can be filled in the more detail. i.e., for example, a table may be entered into indicating the relative target value of the direct cost for the main units and systems of the product, as well as their components, which can be used for interaction with their suppliers. In particular, sending them requests for quotations at the early stages of the project, which are characterized by the absence of economic targets except for those obtained by the use of methods of the value analysis. With regard to life cycle, the use of value analysis techniques is less effective. However, the use of the method of factor research in combination with value analysis techniques makes it possible to assess the effect of the life cycle of reducing the cost of individual components and systems of the product if the output volumes are known. However, this type of analysis doesn't apply directly to technical assignment. And the second, the possibility of reducing the complexity of developing technical requirements and technical assignment according to GOST 15016 for several design options by replacing technical requirements and technical assignment according to GOST 15016 with an alternative form of technical assignment, complete functional model, structured model reports, and etc. at the early stages of the product. i.e., we save resources on creating to approve technical requirements and technical assignment according to GOST 15016, containing many indirect and unnecessary items of technical assignment. And after agreeing on an alternative technical assignment, we prepare the final form of the technical requirements and then technical assignment according to GOST 15016 that includes technical requirements. After that, into accounting the comments of approving the persons. The effects within the format of the alternative form of technical assignment include the first, increases efficiency of a visual perception of the tabular and graphic form of alternative form of technical assignment in comparison with its textual form according to the GOST 15016, which makes possible to provide presentation for the chief design engineer, project manager, and top management of the company. The second, possibility of adjusting design engineering solution based on the calculated values of the significance of the function carriers, the current degree of novelty of the design engineering documentation or design for all products. Other technical and economic parameters and diagrams from the value analysis reports, the possibility of forming a feasibility study for making changes to the design engineering documentation or change management of structural elements for the product reflected in the technical assignment based on the value analysis reports. Third, the possibility of increasing the effectiveness of the use of method of factor research. It's about application of method of factor research on the content of value analysis instead of isolated application. And finally, ability to support commercial negociations using data from value analysis reports. The screen shows the basic diagrams for RQS and for S for the bike and the front wheel form to the basis of the standard functional basis. Such diagrams can be formed to the objects of analysis of any degree of abstraction provided to the source or initial data is available. For example, technical requirements from the technical assignment for the function carriers, target value of direct costs for the object of analysis, i.e. for a bicycle taken from the feasibility study of business plan. Similar diagrams can be constructed for a bolt and sleeve or bushing. However, since these objects of analysis do not belong to the technical assignment level but belong to objects of the lower level abstraction, including objects of the complete structural model and complete functional model level, we will consider them in the practical cases of Block 2 of our training course. RQS diagram refers to the type of the bar charts of histograms. Such a form of presentation of the output data of functional and cost analysis or value analysis in our classification is due to the possibility of visual evaluation of deviations of relative significance R marked R, relative satisfaction marked Q, and actual relative costs marked S. For function carriers in accordance with the structural model of the object of analysis, the magnitude of the deviations makes it possible to determine the degree of balance of structure in the first approximation from the point of view and the context of the above-mentioned characteristics. For example, the diagrams RQS, we do not see significant deviation between expert and actual values, which allows us to assert that the first approximation of the target cost for functions carriers based on the magnitude of their significance are determined correctly and can be used when interacting with company suppliers, i.e. transferred to them within RFQ or RFP. Since the level of consideration of the object of analysis bicycle is maximally abstract, making any specific design engineering decisions. For example, about replacing some elements of the need to redesign them based on the diagram RQS will be incorrect. In the case of the RQS diagram for the front wheel, we see much more significant deviations for individual functions carriers, in particular for bearing and flipper. The presence of such absurd deviations in more cases indicates neither an error in determining the magnitude of significance, but rather an error in information of the structural model. In other words, the bearing and flipper were not at their level of consideration or level of abstraction, i.e., they are compared with more complex components from the constructing point of view. I have already mentioned the options for conditional balancing of the structural model earlier in issue number 8. In particular, we are talking about either the introduction of substitution basis, the exclusion of these elements from the structural model, for example, due to their low cost. The positive and negative sides of the simplification structural model have also already been mentioned above. Although the main negative side is obvious, any simplification introduces an error in the calculation results. It should be noted that the situation when such elements as bearing, fasteners, standard hinges fly to the level of abstracted models is typical to the effectiveness of using mechanism to get out of the situation will be demonstrated more than once of our training course. The reverse situation is also possible at the lower level of abstraction, for example, when constructing complete structural model and the complete functional model or models close to them. In terms of abstraction, we evaluate the significance of purchased products that are obviously more complex in design and function than the details of other function carriers included in the structural model. In relation to the above indicator, QFC relative, denoting relative satisfaction with the functions carrier calculated on the basis of relative degree of satisfaction by the carrier function, RFC relative, which in turn is calculated based on data on failure rate, the opinion of the expert groups, as well as the marketing methodology for evaluating the consumer satisfaction index, CSI. A separate issue of section 1 of block 1 entitled Functional Model, the degree of satisfaction and the quality of the implementation of functions will be devoted to the calculation of the satisfaction indicator, QFC relative, with a separate function carrier, i.e. in the case of bicycle frame, brake system, and etc. Thus, we come to the conclusion that RQS diagram, built on the basis of structural and functional model of the upper and middle levels of abstraction, is suitable for use by such members of the project team and working group as management, cost engineers of fair type, buyers, marketing specialists, or in framework of the development and conduct of commercial negotiations. In the case of constructing RQS diagram of the complete structural and complete functional models, or models close to them, in terms of abstraction, the resulting value of deviations and significance, quality of implementation, and costs for function carriers can become the basis for revising the engineering design of the function carrier. For example, changes in the structural material, roughness values, thickness of structural elements, technology used to manufacture, etc., with the ultimate goal of achieving the maximum balance of the engineering design, i.e. achieving a state in which the three mentioned relative indicators became as close as possible in magnitude. Consequently, the RQS diagram, built on the basis of complete structural and complete functional models, or models close to them in terms of abstraction, is suitable for use by such members of the project team of working group as design engineers, strength specialists, technologists, both the framework of independent development of design technological documentation, and in roles of an integrator specialists, for example, when interacting with third-party design bureaus, carrying out of the direct development of design documentation of purchased products, parts and assembly units of purchased products at the lower level abstraction. As part of the independent development of RQS diagram is used as part of the activities of cost engineers of the first and second types. The chart of the absolute values of the 4S including target, calculated, actual, and MFR equal of costs. MFR, I mean method of factor research, or costs calculated by using of method of factor research. If we make it for function carriers, is a tool for visualizing information about absolute costs in the required currency and allows you to visually access the deviation of target and current direct costs for the function carriers calculated based on the methodology of functional cost analysis from the actual values of direct cost. The fourth indicator demonstrates the possible effect of reducing the actual direct cost for the carriers of functions in the case of applying the method of factor research, or MFR. The 4S diagram can be used in the decision-making process on measures to reduce the cost of product being developed or put in the production. The details of the process of filling out of standard calculation from the construction of diagrams RQS and 4S were omitted in this issue. However, it should be noted that the complexity of filling out the form for the front wheel is slightly higher than for a bicycle, since the front wheel has more complex functional model, in which not one function carriers correspond to one functions, as in the case of bicycle, but several functions. Let's consider an example of the interpretation of the information given in structural and functional models and diagrams and the content of above-mentioned effects from the formation of an alternative from a technical assignment. In terms of effects within the framework of the technical assignment format according to the GOST 15016, the following can be noted. Low. In comparison with the 4 according to the GOST 15016, the complexity of creating of alternative form of technical assignment for several design options, the early stages of the project cannot be demonstrated visually within this issue. However, examples of using data from technical assignment within the analytical process have already been given above, and the long complexity of editing tabular structure and the functionality of models compared with the text model in the case of considering several design engineering options, I believe is obvious. The second, the introduction of the RQS and 4S diagrams in their current into the section economic indicators and technical assignment according to GOST 15016 isn't correct for the reason that only relative indicators can be included in the technical assignment. Therefore, the 4S diagram immediately disappears, and secondly, only conditionally constant indicators, the value of which does not change depending on the technical commercial proposal, and the current design of individual carriers of functions, for example, parts, assembly systems, aggregates of product. Only the indicator can be attributed to such conditionally constant indicators on the RQS diagram, or R1 function carriers relative is the reduced to the end-to-end relative significance of function carriers, which is essentially the relative value of the target direct cost for individual structural elements in the first approximation. In our case, in the section Economic Indicators of the technical assignment, according to GOST 15016, the values of the relative target cost, target direct cost for the main elements of the bicycle and the front wheel are entered in the form of tables. See tables 2 and 3 of technical assignment. In the case of calculating the absolute target price of systems and aggregates based on the relative values given in section Economic Indicators, of technical assignment, we proceed from the fact that the total value of the product, sales price, and marginal profitability are set in the business plan, respectively. On their basis, the target value of direct product cost can be determined, which we distribute the bike systems and aggregates using methods for determining the significance in the value analysis and data on total costs from the technical commercial proposals provided by suppliers. In the footnote to the heading of the table of names of units and systems of the product, it's indicated that this list of target values of direct costs refers exclusively to the basic configuration. The case of generating analytical reports containing the values of targeted direct costs for additional equipment or optional extraversion will be considered by us in Block 2. Generally speaking, working with additional options or optional extraversion is one of the limitations by using the value analysis methodology. Since the structural and functional model of the complex of additional options, in addition to being set out to some extent in abstraction, is in itself a rather complex concept from the point of view of perception. Since being conditional existing independently of the basic configuration, they do not have a physical embodiments separate from the physical embodiment of the body basic configuration of the object of analysis. Indeed, disc hydraulic brakes do not exist by themselves, but can exist only after they are installed on a bicycle instead of the basic tether brakes with a cable drive. In addition, the question arises how to deal with the current value of significance of the basic options, which is, for example, 0.085, i.e., there is a need to describe the mechanism for excluding from that total significance all the functions carriers mechanism pincer brake disc with a value of 0.085 and replacing it with a hydraulic disc brake with a value obviously different from the 0.085. Taking into account the listed difficulties, two approaches to this problem known to me have been formed in practice. So, within the framework of the formation of structural and functional models, there are two possible options for the working with additional options. The first, formation of separate structural and functional model for basic and additional equipment with subsequent accounting and analytical reports and cost that we remove from the product together with standard options, replacing them with more expensive additional ones. And the second, the allocation of work additional options in a separate direction in which the value analysis and value design engineering methods are not used. In practice, both options of working with additional options are used. From the point of view of theoretical elaboration, i.e. the availability of scientific publication, the issue of additional options can be attributed to a little studied area, i.e. in fact to the limitations of the applicability of value analysis and value design engineering at this stage of the development of the theory of these areas of analysis. But in practice, as I have already mentioned, there are solutions to this problem. The case of working with an additional options will be considered by us in a separate issue of Block 2. Regarding the use of various forms of technical assignment, analytical reports of the formation of RFQ and RFP, the following can be noted. When forming an RFQ and RFP can be used data from the technical assignment according to the GOST 15016. The second, data from the alternative form of technical assignment. We will not dwell in detail on the process of the RFQ and the RFP formation, since this process of activity belongs to the responsibility of buyers and not cost engineers. However, we note that in addition to technical assignment, other design documentation such as drawings and 3D models can be used in RFQ formation. If we talk about the project stage, or talking about the pre-project stage, which is characterized by the absence of a full-fledged technical specification and design documentation, then information from the business plan, feasibility study, technical requirements, as well as structural and functional model and value analysis analytical reports can be used when forming an RFQ. Thus, an alternative form of technical assignment is an end-to-end tool that allows you to manage direct product cost regardless to the current stage of the project. And let's consider in more detail the sections of the extended functional basis for a bicycle similar in content to the section of the same name of technical assignment according to GOST 15016. As a rule, each enterprise has its own standard RFQ and RFP form, so we will not be tied to a specific format, noting only that information from the sections of technical assignment presented on the slide can be used from RFQ and RFP. All of these sections are presented in the extended functional basis discussed above and based on a technical assignment. So, the list of data from the technical assignment sections that can be used in RFQ and RFP includes data from the section name and scope of application. In particular, we're talking about the timing of R&D in accordance with the time plan and business plan of the project. Data from the section technical requirements, including data from the subsection product composition requirements for a bicycle, containing a description of the generalized design structure of the product in the case of RFP formation, i.e. an extended version of the request compared with the RFQ. The supplier can be given the full version of the technical assignment, either for a separate unit of system or the technical assignment for the entire product. In most cases, after the conclusion of the NDA, an analog of the section technical requirements in the absence of technical assignment according to GOST 15016 can serve as a structural model from an alternative technical assignment form. The next, data from the subsection main parameters and characteristics. If necessary, description of an individual mass dimensional characteristic of the project. The next, the data from the subsections corresponding to the design engineering structure of product. In the case of a bicycle, it's a frame, handlebar and column, wheels, brake system, saddle assembly, and transmission. The next, data from the section economic indicators, including relative or absolute target values of direct cost for a product, in this case, a bicycle and its main units and systems, a list of estimated cost components of the bicycle product life cycle, and the data from the section stages of development, including a list of planned stages of R&D. After a forced slight deviation from the logic of the presentation, we will return to the description of the effects associated with the changing business processes of design engineering and management accounting. On the issue, the following can be noted. In terms of the increased efficiency of visual perception of the information presented on the diagrams RQS and 4S, in comparison with textual and tabular information, I suggest not to delve into this scientific field to consider the concept of perception, its steps and mechanism, but to limit ourselves to the fact that researchers in such works distinguish concepts such as text perception and graphic information. And therefore, the addition of text and tabular data with graphical result increases the information load of the perceiving subject. However, it can become an addition to either subjective or objective perception. To which of the types of subjective and objective perception can the concept of balanced design introduced above be attributed, i.e., The correspondence between the significance, degree of satisfaction, and the amount of the direct cost for the carrier of functions obviously depends on the level of professional training or level of applied balance design, and obviously depends on the level of professional training, work experience, and other factors. For example, each subject from a group consisting of 4 specialists equally trained in the field of functional cost or value analysis, but having experience as an economist, the design engineer, technologist, and marketer, respectively, with a perceive the concept of balanced design is in different ways, but taking into account the availability of graphic information, the speed of perception can be increased, and the energy consumption for mental and visual work is reduced compared to the text of a table. The second, in terms of the possibility of adjusting design solutions, improving the effectiveness of the use of matter-of-fact research, and supporting commercial negotiations, the possibility of using the output data of value analysis, in particular reports and their graphical representation, will be demonstrated in practical cases of Block 2, 3, and 4. To the above, we can add that the graphical representation of value analysis reports may include such diagrams as comparison of the cost of function carriers and functions for analog products of the previous generation and analog products of the previous generation of products of competent companies. A set of specialized diagrams to support commercial negotiations, and other diagrams depending on the purposes of the analysis, the specifics of the industry, existing business processes, and etc. Based on the analysis of 2 objects of analysis, bicycle and front wheel, belonging to the upper and middle level abstraction of consideration, it's possible to draw a general conclusion about the preference for the use of the induction method in value analysis and value design engineering, i.e., determining the significance of higher-level assembly units based on the results of the analysis of the parts included in them, and how to determine the significance of functions. So, when determining the significance of these carriers, function carriers, simply put, the application of the from general to particular approach, which is extremely popular with individual managers, whose work style is to set a general design concept and top-level target prices or target direct costs and first approximation, within which their subordinates solve lower-level applied tasks with a subsequent adjustment of the values of the first approximation. In the case of the value analysis and the value design engineering, can lead to absolutely absurd results in determining the significance of components and function carriers. The consequence of this conclusion is that abstract structural and functional model, which are essential formalization of structure and values of significance in the first approximation, can be used in the analysis only with the limitations voiced above, and in fact become either a tool for starting the facts of current cost, provided that the costs of the function carriers and functions of the abstract structural and functional model are formed by the induction, i.e. from the bottom up, or by a very crude tool for calculating direct costs of the first approximation. Rudeness in this case means the presence of significant deviation of actual cost from the technical commercial proposal from the calculated expert value of direct costs corresponding to the relative importance of the function carrier of functions themselves. Thus, the text from of technical assignment is essentially an analog of abstract structural and functional model of the upper or middle level abstraction, and it's not suitable for cost management in the design engineering process. Consequently, in the context of managing direct product costs, the next form of technical assignment can be conditionally attributed to a type of management documentation, although it officially refers to design engineering documentation. At the same time, technical assignments can serve as a starting point for the beginning of the design engineering by the valued design engineering method. For example, for the formulation of primary functions for aggregates and systems. Technical assignment is an alternative form. In particular, we are talking about the standard of tabular form of an alternative technical assignment. Allows us to consider levels of abstraction lower than text form and create a description of the set of functions of the designed component as close to reality as possible, on the basis of which it's possible to create 3D models and layers up to the level of details, i.e. the level of complete structural functional models, and etc. Similar examples of conditional reverse engineering, i.e. the creation of 3D layouts and drawings based on complete structural functional models, will be considered by us in the practical cases of Block 2. Taking into account the above, we indirectly confirm the conclusions obtained in the issue number 9, application of the method of factor research and value analysis, about the predominant role of the design engineering department in the formation of cost of product being developed, and therefore the critical importance of the formation of a cost engineering unit integrated into the organizational structure of design bureau. We're talking about cost engineers of first and second types. Thus, in the case of the formation of an isolated unit of cost engineers, for example, as a part of economic department, talking about cost engineers of the third type, we are actually again talking only about stating effect of or assessing the current state and not about managing the cost of a product, since such units, as a rule, operate exclusively with information on abstract structural functional models of the upper and middle levels. An exception may be the use of similar isolated units of the method of factor research, i.e. in this case they fall to the level of complete structural and functional models. However, the effectiveness of the method of factor research in such is low due to the fact that without having structural and functional models and analytical reports, cost engineers and design engineers cannot justify the economic necessity of making changes, since they cannot measure the cost of individual functions in connection with why do such initiatives often remain exclusively on paper. I suggest we end this for today. Put likes, subscribes, all bye.